Hi, and welcome to the Lesson 4.02 Balancing Equations teaching video. These are the Common Core standards that we are using in this lesson. The lesson objective is the previous material that you do need is the vocabulary that we need for 4.02 are as follows. We must understand what chemical equation or reaction is. Sometimes they're referred to as chemical equations, sometimes they're referred to as chemical reactions. It's the same thing. What those are is that it's a representation using formulas and symbols of your chemical reaction. Reactants. Reactants are those chemicals that you start with. Those are what you go get from the lab and you put in your beaker or your cylinder. Okay, so your reactants are located on the left side of the arrow in a chemical equation. Products, well, those are what you produce. That's what you're making. So you start your reaction with your reactants. Your reactants react together and then you form your products. A sample equation, A plus B, arrow AB. So this is actually a synthesis reaction, which you'll learn all about in the next lesson. So A plus B, arrow AB. A and B are both reactants, and then they come together and they're going to form some product. And that product has both reactants to it. And remember, the subscripts may change depending on the common charges, if it's an ionic compound and things like that. Law of conservation of mass is extremely important in Lesson 4.02. It says that mass is neither created nor destroyed in a chemical reaction. So what does this have to do with equations? Well, it's important to understand the law of conservation of mass, as that is why we actually have 4.02 balancing equations. Because when certain elements bond together, they will bond in different ratios, which means we might have to go back and change how much we start with, and we must balance it, because however many atoms we started with must equal the same number of atoms that we finish with. Mass is conserved. So consider the following example. Nitrogen gas reacts with hydrogen gas to form ammonia. Hydrogen and nitrogen are both diatomic elements, so when they are written by themselves, we always have a 2 after them. When they react, they're going to produce ammonia. When you look carefully, we start off with 2 nitrogen atoms. Okay, remember that the subscript 2 indicates how many we have in this compound. So we have 2 nitrogen atoms reacting with 2 hydrogen atoms, and ammonia is NH3. When those 2 elements bond together, they form this formula, 1 nitrogen, 3 hydrogens. And a lot of that has to do with the valence electrons, if you remember that from Module 2. Okay, there's only so many valence electrons, there's only so much space in the orbitals to form the bonds. So when we look at this, we started with 2 nitrogens, we end with 1 nitrogen. Kind of seems like we lost a nitrogen, right? And then when we look at hydrogen, we only started with 2. How in the world can we have 3 as a product? We only had 2 to start with. That just doesn't make any sense. And that's what balancing equations are all about. Is that, you know what, maybe we had more than one of the hydrogen molecules. Maybe we need 2 hydrogen molecules in order to get this reaction going. Maybe we produce more than 2 NH3s. Maybe we produce 3 or 2 or something. We might need more. As previously mentioned, we do need to know our 7 diatomic elements. In equations, when these 7 diatomic elements are by themselves, they will always have a 2 as their subscript. Okay, all other elements, for purposes of this course, when written by themselves, will have just the element symbol. Like calcium, just Ca. Lithium, just Li. Only these 7 will have a subscript after them when they're by themselves, such as in the example we just saw with nitrogen reacting with hydrogen to form ammonia. If you are forming a new ionic bond, that's when you must look at their charges and figure out what their subscripts are going to be. Recall lesson 305 and 308 when we wrote those new ionic compounds. When we balance equations, we cannot change the subscripts. So many students want to do this. Please do not change the subscripts, as the subscripts are what make the chemical. If you change the subscript, you change the chemical and thus the reaction. Look at this. H2O is water. Now if you change the subscript of oxygen and put a 2 there, you might get a reaction to be technically balanced possibly, but you've changed the chemical. It no longer is water. H2O2 is actually hydrogen peroxide. So you must be extremely careful that you're not changing the subscripts to balance. That is not what we do to balance equations. So what do? We are going to put coefficients, which are the big numbers out front. Let's look through an example. Okay, let's look through an example. I'm going to work through this example and show you a good strategy for balancing equations. Like with many things, you don't have to follow this example exactly. Okay, once you get familiar and you get comfortable with balancing equations, you might do it a little bit differently. As long as you follow all the rules, you make sure you don't change those subscripts, you put only coefficients, and it is balanced, you'll be okay. As starting out, I recommend that you make yourself a little data table. Okay, put in there the element and just list all the elements that you have in your equation. Then we're going to make a list of how many of those atoms we have as reactants and how many we have as products. So we've made our total number. We look at nitrogen. As a reactant, I see that I have 2 nitrogens. As a product, I have only 1. For my hydrogens, I have 2 hydrogens as my reactants, and I have 3 as my product. Remember that your subscript tells you how many atoms you have. Now, in my products, if you look at nitrogen, we don't see a subscript, do we? That means we have 1. Why should we make a table? Well, tables help organize challenging or complicated material. It really will help you keep it organized. In balancing equations, it's really easy to miscount, or you have to take 3 and multiply by 2, which should be 6, but you do something silly and you put 5. Little things like that are very easy to do, and making a table will help prevent errors. The second step we want to do is, after we have already made our table, we've written down how many of each element we have, now we want to determine which elements are not balanced. In here we see that both nitrogen and hydrogen are not balanced. So we're going to randomly pick one element. It does not matter which one you start with. A side note on that, for strategy, if you look, hydrogen as reactants is 2, as products is 3. That's kind of crazy numbers. I like to wait for those for the end. So I'm going to start with nitrogen, but once again, you can pick either element and balance it first. It honestly does not matter. So I'm going to pick nitrogen, and I'm going to try to get nitrogen balanced. So I see that I have 2 nitrogens as a reactant, but I only have 1 as my product. The only thing that we can do is put a coefficient out front of the chemical, NH3. Remember, coefficient is the big number. So what number can I put in front of NH3 so that I have a total of 2 nitrogens? If you said a 2, you are correct. And what this means is that I'm going to form 2 of the ammonia groups. Now remember from Module 3 that ammonia looks like this. So I have one nitrogen for each ammonia group. So if I put a 2 out front of NH3, what that means is that I have 2 ammonia groups, which means we must update the table with our new totals. I have now changed the total number of products for nitrogen and hydrogen because molecules come in whole numbers. If we need more nitrogen, we're going to end up having more hydrogen, but that's okay. So I have a total of 2 nitrogens. Okay, we're going to multiply that 2 times nitrogen, and that 2 also gets multiplied to hydrogen. Okay, now this is the tricky part. Remember that for each molecule we have 3 hydrogens, so we end up with 2 times 3, which equals 6. And hopefully in my drawing over here you can see it on the right side. For each molecule I have 3 hydrogens. Therefore, if I have 2 molecules, I have 6 hydrogens. So just remember that coefficient up front is multiplied by the subscript for that chemical. We want to determine if any other element needs to be balanced. Sometimes when you balance one element, the other element will just fall into place. And sometimes you end up balancing 2 or maybe even 3 elements all at the same time. Unfortunately, that didn't happen here. So we're going to have to balance hydrogen. Looking at this equation, I see that I now have a total of 6 hydrogens on the right side, and I have 2 on the left side. Remember, the only thing you can do when you're balancing equations is to put a big number out front of the chemical. What number can I put in front of H2 on the left side so that the total is 6? Now remember, H2 means that it's bonded together. It's a covalent bond. For every molecule, I have 2 hydrogens. If you said I would need the number 3, you are correct. Because for every molecule has 2 hydrogens, this 3 out front tells me that I need 3 molecules. Notice the difference in terminology. 3 molecules. This 2 tells me how many individual atoms are in the molecule. The number 3 out front tells me how many molecules I have. So how many total hydrogens do I have now on the left side? I have 6. 3 times 2, the subscript for that element. Lastly, we want to check the final equation. Double check that you have not made an error. It is super easy to put a number and you've done it wrong, and if you don't double check, you could possibly be submitting wrong answers, and we don't want that to happen. Silly mistakes happen all the time. They happen to me. Once you balance your equation, what you want to do is real quick just go through and double check. On the left side we have 2 nitrogens. On the right side we have 2 nitrogens. On the left side we have 6 hydrogens. On the right side we have 6 hydrogens. And real quick, just to make sure that you feel comfortable with this, this 3 only gets applied to the element directly before it. It does not get applied to the nitrogen. Some students can get confused by that. So NH3. Just remember that nitrogen, it kind of has a 1 there, even though you'll never see it like that. But the fact that there is no subscript there, you really do have a 1. We just don't have to write 1 because the fact that we have a nitrogen written there tells us that we have 1. Summary of the steps for balancing equations. Again, this is not the only way to balance equations. However, I do find the table method to be super effective for students who are just learning how to balance equations. While doing live lessons, I've had many students who have told me it really has helped. However, every student is a little bit different. You may not prefer the table method. I do recommend it though. If you're just starting to learn how to balance equations, please take the few extra moments, write your table, balance your equation. When you're submitting your assignment, you don't necessarily have to include your table. That's just for you to help you get through the problem. So, quick summary of the steps. Step number 1, make your table. Count how many atoms you currently have on each side of the arrow, reactants versus products. That will tell you what needs to be balanced. Sometimes you may have elements that are already balanced. Number 2, determine which elements are not balanced and add a coefficient in front of that chemical to balance it. Update your table with the new totals. Remember, it does not matter which element you start with. Just pick one and start balancing. Step 3, continue this process for all elements until each one are balanced. Update your table with the totals. And yes, I do see I have a little typo in my presentation. I'm sorry about that. So continue for all elements until they are all balanced. Number 4, once all elements are balanced, double check your totals to catch any silly mistakes. Let's do some practice. Now that we've seen an easy way to balance equations by using the table method, we're going to work through 4 practice problems. If you feel comfortable, feel free to go ahead and stop this recording and go about your day. If you would like some extra practice, continue practice number 3. Please hit pause so that you have ample time to complete this problem on your sheet of paper. When you're ready to resume, hit play. Welcome back. So let's start with carbon. Carbon seems pretty easy to balance first. We have 8 on the left side. To get 8 on the right side, all we have to do is put a 8 in front. So we have 8 carbons, but don't forget, it also is going to change your number of oxygen. So both of those are going to change. So we have 8 carbons, and then for oxygen, 8 times 2 is 16, but don't forget that we have the 1 oxygen over there. So we have 17 oxygens now. Alright, so carbon's balanced. Oxygen looks even crazier for balancing, but that's okay because I'm going to save that for last. Now let's go to hydrogen. We have 18 on the right side. I need to put some number out front so that my total hydrogen equals 18. Remember, whatever number I put out front will be multiplied by 2 to get my total. So what number times 2 equals 18? Correct. That would be 9. And so 9 times 2 equals 18. Now don't forget, putting that 9 out front also changes my total number of oxygens again. And so when we look at it, we still have the 16 on the left side, but now we have 9 on the right side. And that equals 25. 16 plus 9 is 25. So right now I have 25 oxygens on the right side. Well, my carbons are balanced, my hydrogens are balanced, and my oxygens are not balanced. I have 2 on the left side, 25 on the right side. I have to get 25 on the left side. So what number can I put in front of O2 so that my total is 25? And a good way to do this is think, okay, what is 25 divided by 2? Okay, 25 divided by 2 equals 12.5, so I'm going to put 12.5 there. Okay, because 12.5 times 2 equals 25. However, we can't have half a molecule, right? Molecules come in whole numbers. We can't leave this problem like it. It is balanced. We have everything balanced. However, 12.5 molecules of oxygen doesn't make sense. We can't have 0.5 molecules. And another strategy tip is if you ever get in this situation, which is extremely rare, but if you ever get in this situation, the easiest thing to do is to multiply the entire reaction by 2. Why we're going to multiply by 2 is then 12.5 times 2 equals 25, and we now have a whole number. Let me clear up this bottom information here. I'm going to delete this. Alright, so I've erased all of that. Now when we take and we multiply the entire reaction by 2, what that means is all of our subscripts we're going to multiply by 2. And what that does is it keeps the same ratio. Therefore, it will still be balanced. Now C8H18, it doesn't have a coefficient out front, does it? So what that means is that it really is a 1. So 2 times 1 equals 2. So we have 2 C8H18. 2 times 12.5 equals 25. 2 times 8 equals 16. 2 times 9 equals 18 waters. And now by me doing that, I have increased all the numbers, but they're all whole numbers now and the same ratio. Okay, if we were to count our elements, you will see. Look at carbon. 2 times 8 is 16. Look at this over here. 16 carbon. My hydrogen, 2 times 18 is 36. 18 times 2 is 36. My oxygen, 25 times 2 is 50. And then I have 16 times 2. Okay, and 16 times 2 is 32 plus the 18 oxygen here, which equals 50. So you can see we're still balanced. We have a lot more now, but we're still balanced. On rare occasion, when this happens, you have to do that. That's the easiest way to get the decimal out of there. Alright, last problem. Go ahead and pause this recording and balance this equation, and then come back and we'll go through it together. And a quick tip on this one. If you want, you can keep the polyatomics together when you're balancing, as long as the polyatomic looks identical from the left side to the right side. Alright, let's go ahead and start balancing. On the left side we have 2 aluminums. On the left side we have 3 sulfurs. Uh-oh, I think I hear a student confused. We haven't dealt with parentheses yet, have we? If you have a chemical in parentheses with a number outside, that subscript gets applied to the element directly before it. But if you have a parentheses, then that subscript gets applied to the chemical directly before it, which means that 3 gets applied to sulfur and to oxygen. Therefore, I have 3 sulfurs, 12 oxygens. But wait, we got an oxygen over here. So we really have 13 oxygens. We have 1 potassium and 1 hydrogen. Alright, so just keep in mind, if you have a subscript and a parenthesis before it, that subscript gets applied to the elements in the parenthesis. Not aluminum, just the chemical in the parentheses. Alright, let's go to the right side, our products. We have 1 aluminum. Uh-oh, we have another parentheses with a subscript. Alright, again, that subscript gets applied to everything in the parentheses right before it. 3 gets applied to the O and the H because those are directly before it. So we have 3 oxygens there. We have 3 hydrogens. Uh-oh, but we have oxygen over here, don't we? So 3 plus 4 actually equals 7. So we have a total of 7 oxygens on the right side of the arrow. We have 1 sulfur and 2 potassiums. All right, Let's continue balancing. It looks like nothing is balanced. So go ahead, pick an element. Any element, doesn't matter. You can start at the top and work your way down. If you think there's an element that might be easier than others, you might want to start with that. Since oxygen has multiple sources on each side, okay, more than one chemical has oxygen on each side, I would recommend to save that for last and just pray it works out. I probably wouldn't start with oxygen. That's hard. That's probably the hardest one to balance right now. I'm going to start with aluminum. I have 2 aluminums on the left side. I have to have 2 aluminums on the right side. Aluminum does not have a subscript, therefore I'm just going to put 2. Now when I do that, it is going to change my number of oxygens and my number of hydrogens. So my aluminum, my oxygen, and my hydrogen are all going to change. We have to be very careful that we're doing this one correctly. A lot of really silly mistakes can be made. I have 2 aluminums. Now this one, remember the 3 gets multiplied to the oxygen, so that's 3 oxygens, and this 2 gets multiplied. So 2 times 3 equals 6 oxygens. But don't forget, we still have these 4 over here. So we have a total of 10 oxygens now. Alright, once again, that was this subscript outside of the parentheses. Remember, that still gets multiplied in. So we have 3 oxygens, and then the 2 out front gets multiplied by it. So 2 times 3. Same thing for the hydrogen. 3 hydrogens here times the 2. 3 times 2 is 6. Alright, so there's aluminum. We can go ahead and get sulfur balanced. On the left side we have 3 sulfurs. On the right side we have 1. Therefore we have to put a number here so that when it gets multiplied by this, it equals 3. Well, sulfur doesn't have a subscript. Therefore, we can just put a 3. Now don't forget, that's going to change K and oxygen. Oh my goodness, this one's long, isn't it? It's long, but I don't think it's terribly difficult. You just have to remember that that 3 gets multiplied by everything after it. So for K, K has a subscript of 2, so 3 times 2 equals 6. We already did our sulfur. Oxygen. Don't forget, we still have the 6 oxygen over here. That hasn't gone away. We still have that 6 oxygen for this molecule. And then on the right side, we have a big number 3 here, and we're going to multiply that by oxygens 4. So 3 times 4 equals 12. So 6 oxygens plus 12 equals 18 oxygens now. So we now have 18 oxygens. So K looks like it needs to be balanced. Well, on the right side we have 6 Ks. On the left side we have 1. Looks like that should be pretty easy to fix, right? Because no subscripts, just put a 6 there. But remember, that's going to change the total number of K, O, and H for the left side. We now have 6 Ks. We now have 6 oxygens and 6 hydrogens. But remember about our oxygen on the over here. This first chemical has 12 oxygen. So 12 oxygen plus 6 oxygen equals 18 oxygen. And then we have 6 hydrogen. And wow, look at that. Our oxygen's balanced. They just balanced themselves out. And that happens a lot when you have polyatomic ions. The oxygens will just tend to balance out. Thank you so much. It's been great working with you for balancing reactions. You are going to need to be able to balance reactions for future lessons in Module 4. Pretty much all of them require it in Module 5. So please make sure that you're doing the practice in the lesson, and feel free to come into the live tutoring if you have additional questions, or you can use all the recorded help that we have available on your teacher's announcement page.